Welcome to Creative World. In this video, we will solve Chapter 3 exercise problem number 3.17. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is equal to the product of current through it and the value of resistance itself. Now move towards the problem. Exercise problem number 3.17. Use nodal analysis to find the value of voltage V0 in given below figure. This is the circuit diagram of given problem. Inside this network, we have to find the value of voltage across this 1 kilo ohm resistance labeled as V0 with this specified polarity. And we have to use nodal analysis technique. So without wasting time, let's proceed towards the solution of the network. We know that in order to apply nodal analysis on any network, we have to follow some steps. First step includes finding out the maximum number of node voltage equations that can be retrieved from that network. So using this equation, we can find out that figure. In this equation, n represents number of nodes exist in that network. In our case, there are 4 number of nodes, so 4 minus 1 will be equal to 3. Maximum 3 number of node voltage equations can be retrieved from this network. In next step, we have to label all unknown non-reference node voltage. In this network, we have made this node as reference or ground node in order to make simple calculations. Normally, we make the bottom node of the network as reference or ground node. If we will make this node as reference and ground node, this voltage source will come between two non-reference nodes. So this problem will lead to supernode analysis. So that's why in order to restrict this solution only to node analysis, we have made this node as reference or ground node. Now this voltage source is not coming between two non-reference nodes. So the circuit can be solved using simple nodal analysis technique. Other three non-reference nodes voltage are labeled as V1, V3 and V2. One more thing to notice, this voltage V3 will be equal to 12 volt because of this voltage source which is connected between node 3 and reference or ground node. And the positive terminal of this voltage source is connected to node 3. That's why the value of V3 will be positive 12 volt. In next step, we have to assume all unknown branch currents along with their directions. Now we will apply Kirchoff's current law one by one on these three non-reference nodes to find out their voltage equations. We will start from here. On this node, one current is entering 4 milliampere while two currents are leaving I1 and I2. Entering current is taken with positive sign and leaving currents are taken with negative sign. Now we have to replace these two currents with their respective equations. Current I1 will be equal to voltage across this 1 kilo ohm resistance with respect of this reference node, that is V1. V1 divided by 1 kilo ohm will be equal to I1. Similarly, current I2 will be equal to the potential difference of these two node voltage divided by the value of resistance, V1 minus V3 divided by 2 kilo ohm. Here the direction of current I2 is from node 1 to node 3, which is indicating that voltage on node 1 is on higher potential than node 3, and the value of voltage V3 as we discussed earlier is equal to 12 volt. So current I2 will be equal to V1 minus 12 volt divided by 2 kilo ohm. Now in order to omit all denominator values, we will multiply this equation on both sides with 2 kilo ohm. Product of 2 kilo ohm and 4 milliampere will result 8 volt. Here product of 2 kilo ohm and 1 kilo ohm in denominator will cancel out with each other, only 2 will left, and that 2 will multiply with V1, it will become 2V1. Here the product of 2 kilo ohm and 2 kilo ohm in denominator will cancel out with each other, only V1 minus 12 volt will left. Now we will open these brackets and multiply variables inside brackets with minus 1. The equation will become 8 volt minus 2V1 minus V1 plus 12 volt. Now add these constants together and add these two variables together. the equation will become minus 3v1 plus 20 volt. Place this 20 volt on the other hand side of equal to calculate the value of v1. Divide on both sides with minus 3. The value of voltage v1 will be equal to 6.67 volt. After calculating the value of voltage v1, now we will apply Kirchhoff's current law on this node. We don't have to apply Kirchhoff's current law on this node because the voltage on this node is already given in the form of voltage source, and the value of this voltage v3 equal to 12 volt. So on this node only one current is entering, I3, while two currents are leaving, 4 milliampere and I4. Leaving currents are taken with negative sign and entering current is taken with positive sign. In next step we have to replace these two currents with their respective equations. Current I3 will be equal to the potential difference of these two node voltage divided by the value of resistance 1 kilo ohm. Here V3 is equal to 12 volt, so 12 volt minus V2 divided by 1 kilo ohm will be equal to I3. Here we have subtracted V2 from V3 because of the direction of this current I3. This current I3 is flowing from node 3 to node 2, which is indicating that voltage on node 3 is on higher potential than node 2. Similarly, current I4 will be equal to V2 divided by 2 kilo ohm. Now, in order to omit all denominator values, we will multiply this equation on both sides with 2 kilo ohm. Product of 2 kilo ohm and 1 kilo ohm in denominator will cancel out with each other. Only 2 will left, and that 2 will multiply with 12 volt minus V2. Here product of 2 kilo ohm will cancel out with 2 kilo ohm in denominator. Only V2 will left, and here the product of 2 kilo ohm and 4 milliampere will result 8 volt. Now open these brackets. 2 will multiply with 12 volt, it will become 24 volt, and 2 will multiply with minus V2, it will become minus 2V2. Add constants together and variables together, the equation will become minus 3V2 plus 16 volt equal to 0. Place 16 volt on the other hand side of equal and divide on both sides with minus 3 to calculate the value of voltage V2, that will become 5.33 volt. Now we have the value of voltage V2 as well as the value of voltage V3. So the potential difference between these two nodes will be equal to voltage across this 1 kilo ohm resistance. And we are interested to calculate its value, which is labeled as V0. So we can say that V0 will be equal to the potential difference of these two node voltages. Now the direction of current I3 is from node 3 to node 2, which is indicating that voltage on node 3 is on higher potential than node 2. So the potential difference between these two nodes voltage will be taken as V2 will be subtracted from V3. Now we will replace V3 and V2 with their respective values. V3 is equal to 12 volt and V2 is equal to 5.33 volt. Subtract 5.33 volt from 12 volt, the answer will be 6.67 volt. So the value of voltage across this 1 kilo ohm resistance labeled as V0 with this specified polarity is equal to 6.67 volt. So this was all about chapter 3 exercise problem number 3.17. Thank you. See you again in next video.